Okay, so now we will study faculae. Now we see sunspots. We all know what sunspots are. We will study the sunspots in detail as well. When we look at the sunspots, we see just around the sunspot, the regions are very bright. So we see bright areas around the sunspots. Okay, these sunspots occupy a substantial fraction of the solar disks. So these areas are known as the faculae. Now these are these phenomena. This belongs to the transition region. This phenomena belongs to the transition region of photosphere and chromosphere. So this is why we said earlier that these are chromosphere features as well as photosphere features. And we already said that these transition regions, these layers within a star is not very fixed. These there are transition regions that are about 200-300 kilometers thick, and for bigger stars it's even bigger, and for different kinds of stars the layers are different. But yes, I mean, essentially these layers are not fixed. So this is predominantly a feature of the transition region. So we observe both photospheric faculae and we observe chromospheric faculae. Now these photospheric faculae are observed near the limb because these are not very bright. So what happens is, just like we cannot see the stars in the morning sky, they kind of lose the contrast, and because of losing the contrast we cannot identify the stars, but the stars are there in the morning sky. Just like that, photospheric faculae are observed near the limb. Near the limb the brightness is less, hence we can observe the photospheric faculae, and on the disk we cannot observe them because they lose contrast, but they are there. The chromospheric faculae are much brighter than the average brightness of the disks. So that's why chromospheric faculae can be observed, is visible in the bright chromospheric lines. We usually see the lines like in H and K lines. and also Ca2 lines. And the brightness of these faculae almost remain unchanged over the entire disk of the Sun. Now, these photospheric faculae, we already said that these are the bright areas around the sunspot. So whenever there is a sunspot, there are bright areas around it, and those are the faculae. Okay, they are associated with the sunspots. But usually the spots are short-lived. Spots are like the average lifetime hardly exceeds a month. Okay, but this faculae stays longer. They appear before the spots. So the faculae, they appear before the spots. And the stays about, in some cases, they stays for about 200-300 days. Okay, and there are faculae which are not associated with the sunspots. There are faculae, but they are invariably smaller and fainter and relatively short-lived. So now why these? We all know that the sunspots are solar activity, faculae are solar activity as well. But the largest individual faculae generally occur at the time of the maximum activity. 2 to 3 years after the maximum activity, the individual faculae starts getting smaller and smaller, and they become fainter, then they vanish. So the average lifetime of a granule, like we already said in the previous lecture, that the average lifetime of a granule is about 8 minutes. And this photospheric faculae, just like the granules, granular structure of the photosphere, the photospheric faculae also has a granular structure. So this photospheric faculae, they also has a granular structure. Now we observe the chromospheric faculae using this H and K lines and Ca2 lines. These are studied more extensively, okay, because these are more bright. Now this, when we see there are certain characteristic differences between these lines. So the faculae, the structure of the faculae that gives us these lines are kind of more compact and even shaped. Even shaped. You can recognize a shape there. And the faculae that gives these lines are kind of patchy. So why these faculae forms? What is the origin? Now this origin is not what should I say, not very well known. They exhibit a very peculiar temperature distribution. Cooler below and hotter above the surrounding gases. I mean, this seems that there's a kind of forced supply of energy. Force supplied of energy in those parts, hence those parts becomes very bright. Now we do not know whether these supply are maintained by the convection currents or by the magnetic field in the subphotospheric layer. This we do not definitely know. Now faculae, we said that these are associated with the sunspots, and although there are very few faculae without the sunspots as well, but mostly they are associated with the sunspots. But now there are sunspots and there are faculae, and we see that the sunspots has a period of existence. Faculae has a different period of existence. So we cannot say that these sunspots and faculae has some causal relationship. We cannot establish that. I mean, this doesn't establish a causal relationship between these two, cause-effect relationship. So what we consider is the sunspots and faculae. These are both caused by some common cause. So these are manifestations of some kind of a third agent. And what is that agent? We do not know. The best candidate so far is the subphotospheric magnetic field. Now next we will study the chromosphere. Chromosphere we will just like these. I mean, these lectures are more descriptive because there is nothing much except you see that the discussions in the Rayleigh number, but that's too is more descriptive physics here. And then chromosphere and corona, we will discuss some more descriptive aspects, and then we go into the mathematical part of the solar studies, like the cycles and in the magnetic fields. When we study the solar magnetic fields, so those will be more mathematical aspects, theory of sunspots and things like that.